Welcome everyone. The topic for our report was technologies for higher MPG vehicles. My name is Frank Delau,
I'm Christopher Chung.
And I'm Ricardo Charleston.
and this is our presentation. The division of work happily taken care of by our team leader, Christopher Chung, was that my part was the future work, conceptual design, and conclusion discussions.
I did the background, literature survey, and ethical statement.
I, Ricardo Charleston, did the current designs, the introduction, and the references.
The problem statement for this report was that we use historical background and current designs to try to either improve a current design or create a completely different conceptual design.
Okay, and a little bit of the background of high fuel efficient cars. Fuel efficient cars are something of recent times. Back a couple hundred years ago, when cars first came out, they used traditional method of internal combustion engines, and these did not yield very high gas to mileage ratios. In the late 1900s, we're seeing the beginning of efficient cars, high fuel efficient cars, come to light, and ever since then, every year, we have been seeing a higher ratio being increased of the gas to mileage ratios. Today, the unprecedented numbers of what is being achieved, and this is really a testament to the great engineering and great technologies that are being available to us today. And some of the across in Asia, the Japanese, they have always been really pushing the limits when it comes to high fuel efficient cars. And two of the most prominent automakers, Honda as well as Toyota, have been no new players to the game, but have been around for a very long time, and they continue to push the envelope when it comes to this. The Honda Civic Hybrid achieves 44 miles per gallon in the city and 47 miles per gallon on the highway, whereas the Toyota Prius achieves 48 miles per gallon in the city and 51 miles per gallon on the highway. These are the two more popular fuel efficient cars that are on the market today. The American auto industry has also taken note of this, and they in recent years have also been putting forward cars that are more fuel efficient and achieve better gas to mileage ratios. Companies such as Ford have really been taking steps towards reaching this goal. Yeah, and with technology advancing and engineering advancing at the rate it is, I think it's only a couple of years before we see a car that has been produced that is 100% fuel efficient, that is green. Yeah, on the literature survey, as I said before, the late 1900s is when we really saw the evolution of this industry begin to take place. And what this was the start of it, when really what paved the way for what was to come today. And since then, it's been a norm for people to consume and for automakers to produce vehicles that are very efficient, and something that wouldn't have been able to be done a couple of years ago. So, and it's great for everyone, for the consumer, for the producer, and as well as for the environment. And if you look here, you could see the Porsche Siempre Vivas. And this came out more or less in the 1900s when this technology began. Yeah, and it's a very good example of what paved the way and what started it all for high efficient vehicles. That's it for my part. I'm Christopher Chung. I'll now hand it over to my classmate Ricardo Charleston.
All right, thank you, Christopher. I'm gonna go ahead and continue with the current high efficiency technologies available in the market nowadays. We have the EcoBoosts, the hybrids, and the plug-in hybrids. The EcoBoost is the direct injection along with a turbocharger adding together to provide power at perfect low and torque responsiveness. And the hybrids, which is an internal combustion engine with electric motors that gets recharged through regenerative braking. And we have the plug-in hybrids, which get recharged, which gives you more option to recharge your car at home or at any charging station. Here are the improved specs that increase MPG. First of all, we have the cylinder deactivation that will keep the cylinders idle when they are not in use. We have the start-stop systems, which will rapidly shut the car off when the car reaches a complete stop. Next, we have a gasoline direct injection, which is the main idea of the air, the mixing of air and fuel to make it cooler. And we have the number of gears. The more gears your transmission has, the more efficient your car is. And then we have the continuously variable transmission, which is a single speed transmission. And we have an automated manual transmission, which works as a dual clutch that combines the manual transmission and the automatic together. That was it for the specs. I'll let Frank go and talk about the conceptual design.
Thank you, Richard. And here, as you can see, this is our conceptual design. What we added, the improvements we did was the solar panel, where the solar panel will help the generator create electricity for the electric motor. And as you can see as well, the shaft where the electric motor it has a larger gear. And this ratio between the larger gear compared to the smaller gear at the top here, you can see that the electric motor has to apply a little bit more torque, but the electric generator will be having more charge due to the higher angular velocity on the smaller gear. Here we can see over here at the corner, with the help of SolidWorks Motion, we can see here that the angular velocity of the electric motor is at a constant 480 angular degrees per second, 480 degrees per second. And at the top you can see the angular velocity of the engine, which is also the angular velocity of the generator, spinning at 960 degrees per second, double, like we said before, due to the gears. And that's that part. And then the future developments we'll be looking into after my current design, after the conceptual design, we look into the efficiency of solar panels. Unfortunately, solar panels are only 10% efficient. Some range between 10 to 11. And so what we look into is maybe that, and also the solar panels are linearly increasing in efficiency. This, so at some point we can be using solar panels more efficiently on our cars, and so that they can help the hybrids take solar energy that is usually lost as heat onto the surface area, change it into electrical energy for the hybrids. And then we also have the consumer interest, where solar panels usually are dull colored or navy blue, as seen on the photo, that they do not look great onto the eyes of the consumer due to their color compared to the color of the vehicle. That's another concern. And the last concern is dangerous voltages due to the generator. At high angular speeds, we will be creating large amounts of voltages. This could be fixed with a clutch, in which the clutch will deactivate the generator at certain high voltages. And the conclusion, where we would use the impact of solar panels to come, where we would see into better technologies of the solar panels. Well, since they are increasing in efficiency, we can then use them on hybrid vehicles. Also, the high MPG vehicles can be used later on in the future because of soaring gas prices. At some point, gas prices will increase and rise, of course, due to the loss of gasoline, and then we can use solar panels on our hybrid vehicles to then propel them and conserve electrical energy and solar energy lost by heat. Thank you, everyone. This is the end of the presentation. Thank you so much.